Okay, so let's enter into the demo world. The demo for authentication especially will be a little different than the other Kubernetes demos because as you already know that authentication is not handled in Kubernetes, it is handled outside. But even before going into the authentication, you might ask that how we have been able to do so many things so far. I talked about authentication so much, and I also said that only once you are authenticated, you would be able to execute the kubectl commands like kubectl create pods, create services, create deployments, etc. But so far, we have been able to do so without any problem. How was that possible? Now, for that, you have to understand a configuration file, and configuration file would be for kubectl, and that configuration file is there in .cube directory. So, what is this .cube directory? If I go to the command line, I have SSH'd into the master node and I am in the home directory of this particular user. If I type lsla, you see I have this .cube directory. Now, what is this directory? So this is the directory where kubectl gets information from. And this directory contains a file named config. And this config file is used by kubectl only. The way it happens is that we have this master node, and of course we have the API server in master node. What we have done, we have SSH'd into the master node so far, and we were able to execute kubectl commands. And kubectl commands go to the API server. Now we did not have to do any authentication whatsoever. So as I had shown you, there's a folder .cube under which there's a file config, and that is there in the user's home directory. So what kubectl does is, kubectl always consults this file whenever we submit any command. And this file actually contains authentication information about the user that I'm using to submit the kubectl commands. Once it is authenticated, once kubectl consults this file and gets satisfactory response, then it can go ahead and submit the command to API server, and API server already gets an authenticated user. But API server knows that this user is authenticated. Now, the question might arise, where did this file come from? This home directory /cube.config. We did not do anything so far. So if you remember, when you created or when you executed kubeadm init command, we got something like this. This was something that we had to do. So we had created a directory in the user's home directory, and we actually created this .cube directory. And under this directory, we copied this file from hc-kubernetes/admin.conf to this file in the newly created .cube directory. And then we changed the owner of that file to the user that we were using. Now notice the highlight here. We have copied this admin.conf file, which means that when we install Kubernetes, we already get this admin.conf file, and if you copy this admin.conf file to any user's home directory, that user gets the similar access. And this is where we got this file from, or this directory from. Let's take a look at the directory a little bit more detail. So I'm in the home directory of the user, and this is the user, deep_cloud2208. And I have, of course, this .cube file. If I go to this .cube file, .cube directory, and we have two directories and one file. And the file that I am bothered about is this config file. And if I open this config file, I'll see a lot of information, and it is also a YAML file. So the API version is v1, and then we have clusters. And in clusters, we have an array. The name of the cluster is Kubernetes, and the IP address and port number where this master server of this cluster is running is 10.20.149, and the port number is 6443. Then we have certificate authority data, which we get by default when we install Kubernetes. So this portion, this entire portion, is the certificate authority data, and we use it for other users also. You leverage this data to create X509 certificates for other users also. So this is the first portion. We have clusters, which talks about the name of the cluster, the IP address and port of the cluster, and certificate authority for this cluster. Then you have something called context. Context actually sets the user for their cluster. Now, if you see in the context, we have the same cluster. The cluster name is Kubernetes. User is Kubernetes admin. And the kind is config. And if you see, then we have users. And in users, we have Kubernetes admin with two things. One is client certificate data and client key data. Client certificate data is actually the certificate signing request data for this user, this Kubernetes admin user, and client key data is the private key of this user, which is Kubernetes admin. Now, we did not do anything. It was given to us automatically the moment we created the cluster using kubeadm init. So there are three things essentially here. As far as key is concerned or certificate is concerned, we have certificate authority data, then we have client certificate data, which is actually the approved client certificate, and then client key data, which is the private key of the client user, or the user rather. So in this case, the user is Kubernetes admin. We'll see this, we'll create our own user later on, and we'll create this context and cluster and config file ourselves also. But as of now, I just wanted to tell you that so far as we logged in this particular node, now what happened so far is whenever we had typed this kubectl commands, any commands for that matter, this kubectl command went ahead and consulted this config file and said whether the access is there or not, or the authentication is there or not. So now as this user has this .cube.config file in its home directory, so the user authenticated to the API server using this config file, and API server gave us the output back. Now one more question arises is that can I use operating system user to authenticate to the API server? The answer is no, because of one thing, because of this same .q file. Let me show you. Let us create an OAZ or operating system user and try. So I'll log in as root, and then I'll add a user, and the name of the user would be, let's say, Deep, and I'll have to provide a password. So the password has been provided, and the remaining thing I can keep as is, and now the user has been created. So if you type id Deep, if you see, this user has been created, and I used this add user command to create this user. Let me create one more user, let's say developer, and it is asking for the password. It's fine, provide a password. The remaining things you can just keep it as is. So I have added two OS level user, one is developer and the other one is Deep. Now let's do one thing. Let's try to log in as one of the users and try to run the kubectl command. So I have logged in as Deep, and if I try to run this command, it will give me error saying that connection to the server localhost was refused. Now it is the same error which we had seen long back while creating or restarting the Kubernetes cluster. Now you know why do we get this error? We have to copy those files. So which files? We have to create those directory and copy the config file. So I've created this .cube directory. So as you can see, it has been created. I cannot use sudo from here because this user does not have any sudo access, and it says permission is denied. So what I'll do is I will log in as root again, and I'll copy this file to the home directory of that user. So this is the file, and I'll copy to the home directory of that particular user in the directory cube and in the file config. So this has been copied over, but the problem is that this user does not have access to this particular directory. Root is the owner of this file and the directory. So let us change this. Okay, so I have changed the owner. Now if I type this lsl command again, you'll see that the owner has changed. It is Deep now. Don't worry about these commands. You just copy and paste whatever I'm doing. If you don't understand, that is fine, because anyway will not be using this. Okay, so I'm back to deep_cloud2208 user. Let me log in as Deep. So now I am logged in as Deep. If you see, ID is Deep. Let me try to run kubectl get pods command, and you can see that I am getting the output, and hopefully enough I'll be able to create. So this is the command kubectl run. The name of the pod would be busybox2 and the image would be busybox. Now if you see, this busybox deployment has been created. If I do get pods, I'll be able to see this pod in the prod namespace. I have created this deployment in prod namespace. So kubectl get pods, and if I type that namespace, I'll be having this busybox2 pod here also. Not only that, it has created a deployment as well. So this is busybox2, and let me go ahead and try to delete this. Now let me go ahead and delete the existing pod which was already running. Let's see whether we can do that. Alright, so this was also deleted. Do a get pods or get deployment. We have only one deployment remaining. So as you can see, we have given unlimited access to this user Deep, which is an operating system user. We created the user just now, and we just copied this .cube config file admin.com to this user's home directory, and then to .cube directory, and then to config file. So we just copied that file hc kubernetes admin.conf, and this user got unlimited access. So that's why we should not use operating system user for authentication. We should never use operating system user for authentication or for authenticating to API server. So now what we'll do is we'll go ahead and create a user and use X509 certificate to authenticate that user. But the user would be outside of the Kubernetes cluster and will be created in a different machine.